Welcome to The Owl Hoot, a podcast for the environmentally curious, with me, Caroline Norbury. On each episode, I chat with a guest who contributes in some way to protecting the planet on matters of climate change, sustainability, biodiversity, and pollution. Here is a place where you can gain new knowledge and be inspired. Enjoy listening. Today I am talking with Dr. Steve Smith, Executive Director of 2 climate initiatives at the Smith School, University of Oxford. Following his doctorate in atmospheric physics at Imperial College London, he went to work for the Committee on Climate Change, becoming Head of Science. He then joined the UK Department for Business, Energy and Industrial Strategy, where he co-led the climate science team and was involved in legislating the UK's net zero target. Steve not only communicates climate change to governments and businesses, but has also helped write books for young people, including Usborne's Climate Crisis for Beginners. I'm delighted to have him on the podcast and share his insight into his work regarding net zero and greenhouse gas removal. Welcome, Steve, to the podcast.
Thanks for having me.
You are most welcome. So I'm going to get straight into it and find a little bit more about you by asking, what can you tell me about your background that has led you to a career focusing on in and around climate change issues?
Oof, I don't know how far you want me to go back.
As far as is relevant.
I guess I've always been a bit of a science geek. So growing up as a boy, as a teenager, I grew up in Derby, actually, and I was always into physics and science fiction. So I imagined that when I grew up, if I didn't become an astronaut, I'd probably become some kind of scientist. So I had that interest going up through school, and when I thought about what I wanted to study going to university, I latched onto physics. Physics, chemistry always interested me, but climate and the environment wasn't really part of the curriculum. So I was more excited by space and topics like that. But it was towards the end of my physics degree, I think, that climate change was going up the radar, and so I still had an interest in science. But I was thinking, I guess through my studies, I realized that I wanted to do something that was quite relevant to society and not just think about theories and concepts all the time. I went on to study for a PhD at Imperial College London, as you say. Actually, funnily enough, the more study I did, I think the less of an idea I had of what I wanted to do. But I was quite interested in writing and communicating. I entered a few sort of kind of science writing competitions, and there was an opportunity that came up to actually have an internship in Parliament. They have this brilliant Parliamentary Office of Science and Technology, which provides a lot of science and technology expertise to members of the House of Commons and the House of Lords. And students, researchers often get opportunities to do little internships and write what they call a post note there. So I did that, and that got me interested in policy, I guess, and sort of the applications of the atmospheric physics I was studying. And it was about that time, actually, that the Intergovernmental Panel on Climate Change published their 4th assessment. So they've done 6 now. But that bumped things up the news, and people were talking a lot about climate. And I guess the real bit of good fortune that put me on my working path was, as I was finishing my PhD, the government was just putting through this new climate change legislation, what's now the Climate Change Act, which said we are going to commit to a legally binding target for the UK's greenhouse gas emissions in 2050. And we're going to have a series of carbon budgets, these kind of limits to get us there. And we're going to create this new organisation, this group of independent expert advisors called the Committee on Climate Change. And no one had heard of this at the time, but they filled the Committee on Climate Change at the kind of working level with lots of brilliant economists and hotshot civil servants, and they realised fairly quickly, I think, that they needed a scientist. So they put out an advert for a scientist, and I kind of responded to that advert. And within about 3 weeks, I think, I was in the office getting to work on doing research on what the UK's 2050 target actually should be. And so we advised it should be at least an 80% reduction below 1990 levels. That was my kind of first big thing out of my PhD. And I think I've kind of formally applied for my own job about a year later. So spent about 9 years then working at the Committee on Climate Change, the CCC, had a really interesting, really fun time there, looking at lots of aspects of climate policy as a scientist, but working a lot with people who are asking, well, how do we actually decarbonize a country like the UK? What are all the implications for how we generate electricity, how we travel, how we generate food, and so on? So I got really interested in the kind of pathways for how we deal with climate change, particularly at a national level. And then I moved into government, helped lead the team of climate scientists they have there, as you mentioned. And that, funnily enough, was at the time when the UK was revisiting what its 2050 targets should be. So I felt like my job sort of did a complete cycle at that stage, and I was involved in addressing the question of what should that be. That was off the back of the Intergovernmental Panel on Climate Change's special report on 1.5 degrees. So these IPCC reports, they do kind of generate big milestones. And we said it should be at least a 100% reduction. In other words, net zero emissions by 2050. And then through that, I guess, with my interest in climate science and how we decarbonize, I was increasingly getting involved in conversations about carbon removal. So in addition to reducing emissions, this idea that we might actually have options to, we might need to use these options to take carbon dioxide and maybe other greenhouse gases out of the atmosphere to balance out any residual emissions, or maybe go beyond net zero even. And the UK research councils decided that they wanted to fund a project on this. I was able to move to the University of Oxford to the Smith School of Enterprise and the Environment, although the Smith is no relation, I have to clarify. And I'm now involved in leading a big research program, as you said, core on carbon removal, and also involved with Oxford Net Zero. So I guess I've always had a career that's been a little bit at the interface between climate science research, decarbonisation research, and then what we actually do about it in terms of policy.
Yeah, quite an exciting breadth you've got going on there. And I imagine that poses all sorts of interesting challenges, which I'm sure we'll come to. In the first instance, then, let's talk about the net zero side of your role. You're involved with Oxford Net Zero. Perhaps at this point, it would be a good idea to just clarify what we mean by net zero.
Sure. Net zero as a concept, it did come out of climate change research. Actually, I work very closely with Professor Miles Allen here at Oxford, and he's often called the scientist behind net zero. He did a lot of the really crucial research, which kind of created the concept of net zero. It's really grounded in the fact that if you run lots and lots of climate change models, and if you take the best understanding we have of the global climate system, despite all the complexity of the system, this really neat, quite simple relationship emerges between how much fossil CO2 you put into the atmosphere over time and how much global warming we get. So even though if you look at global temperature over the kind of thermometer era we've got the last 150 years or so, and you see these kind of lots of natural wiggles, but then you see this clear long-term trend upwards. If you plot that against how much CO2 we've emitted up to that point cumulatively, essentially since the start of the Industrial Revolution, you get this remarkably simple linear relationship. It has little wiggles in it through natural variability. But actually, how much warming we get and how much warming we will get in the future is mainly determined by the total amount of CO2, fossil CO2 emissions we put into the atmosphere. Now, the corollary of that is if we want global temperature to stop rising, we need that cumulative CO2 amounts of emissions to stop. So we need our additions of CO2 into the atmosphere to go to zero. Or what the atmosphere is really seeing is our net additions. So the concept of net zero is that actually, if we could put some emissions up there, but as long as we take out an equivalent amount permanently, then actually we're at net zero additions of CO2 to the atmosphere, and we will limit global temperature that way. So, of course, now global leaders have signed up through the Paris Agreement to limit global warming to well below 2 degrees and pursue efforts to 1.5 degrees. Whether we want to stabilize at 1.5, at 2, at 4, or at 5 degrees, actually, we have to get to net zero CO2 emissions ultimately to do that.
So you're describing effectively like a weighing balance, aren't you, in terms of the amount that's going in and the amount that perhaps is coming out to try and equalize it to get to net zero, yes? In terms of emissions versus carbon removal. Which is more important, the reducing emissions or capturing more carbon out the atmosphere? If that's an easy question to answer.
Well, we are putting about 40 billion tons of carbon dioxide into the atmosphere through our activities as a global society every year. So the climate is massively out of balance because we are putting net a huge number of billions of tons of CO2 into the atmosphere. We are actually doing a very small amount of removals. Some work I've been doing recently has actually tried to quantify that because remarkably, we haven't really had a clear answer to simple questions like how much carbon removal is going on at the moment until fairly recently. We're removing something like 2 billion tons a year, mainly through what we do as humans in terms of our activities on land, trees and soils and so on. But we're putting into the atmosphere way more than we're taking out. And so all pathways which get us to net zero in time to meet the kind of temperature goals in the Paris Agreement, they all involve a huge amount of emissions reductions. So if you want to weigh importance in terms of the bulk of the amount of mitigation effort we do to get to net zero, clearly it's going to be through emissions reductions. But what we see actually is that in an awful lot of pathways to get us there in time, we will struggle to reduce all of our emissions completely. There are a lot of things we can do very sensibly and very affordably now to cut our emissions. And so in a sense, that's the real crucial work in the, now and in the next few years. But there are some emissions which are going to be very hard to reduce, or we might not be very confident that we can fully reduce, by the time of, let's say, about 2050, if we want to get to net zero globally by then. There are things like our use of land in agriculture. There are fundamental CO2 process, chemical production processes, like the way we make cement. It's just kind of hard to avoid CO2 from that. If people want to fly, it's kind of hard to see how we'll completely decarbonize all aviation on that timescale. So actually, a lot of pathways involve some carbon removal as well. A few billion tons, maybe. Of course, the exact amount depends on how we choose to cut our emissions. But actually, there's over 500 pathways, global pathways, that the latest IPCC report looks at that keep warming to at least below 2 degrees. And all of them involve some scale up of carbon dioxide removal. So, most of the work is going to be through reducing emissions. But I think both emissions reductions and carbon removal are going to be important if we want to meet our climate goals.
Is there any issue around net zero in terms of if you roll out the idea of net zero to business and organisations that they go, oh, well, this is too difficult to sort. Don't worry, I'll find a way of carbon removal to sort those difficult ones out. How do you emphasise the focus on emissions?
I think there's a really interesting thing that happens when you take net zero as a scientific concept that applies to the world, and you then apply that to either an individual country or an individual company, because there the net can become quite different. You're no longer talking about the whole system, but you're talking about an entity within it. And so you get into questions of, well, what portion of global total emissions is that individual company or that country or that individual person actually responsible for? Is it just what they do directly? Is it their wider carbon footprint? Is it, stuff that happened historically and so on? And also the net is often used not just to mean carbon removal, but to include this idea of carbon offsetting as well, which is, let's say I want to take a flight, but I feel bad about flying and I want to do something about the climate impact of that. So what I can do is still take the flight and still have those emissions, but I can offset them by buying a credit for a project which is planting trees on the other side of the world. So, or it might even be a project to install new solar panels or put in clean cook stoves somewhere. So it doesn't have to be a carbon removal project. And there are all sorts of issues then in terms of carbon offsets as to how they stack up in terms of net zero action. So actually net zero at the kind of company level, yes, does become a bit more of a knotty concept. And I'm involved in a net zero tracker, for instance, which is this big webpage, zerotracker.net, where we track net zero pledges by countries and major companies. And we kind of do some basic sense checks of how robust those net zero targets really are. So when are they pledging to go to net zero by? What do they say about offsets? Do they have interim targets which show you that they're actually getting on with things now? Because what really matters is cumulative emissions over time on the path to net zero, as well as just getting there. Do they have a published plan for how they intend to achieve it? Do they regularly report on progress against it? And I think a lot of those kind of issues around transparency and actually saying how you intend to do it can help address some of these concerns and worries people have about net zero as a target.
And what are you finding when you look at that sort of data? Because it's easy to, isn't it? It's easy to go, oh yeah, we'll just go net zero by 2050. That's our aim. Marvelous, sorted. Put that into the website. How are you actually seeing the work that's being done that's then driving the process that will allow those targets to be met?
So, I mean, some headline stats from our net zero tracker are, if let's say we look at the companies, so we look at the 2,000 largest publicly listed companies in the world, and actually just over 700 now, I think, have net zero pledges. So over a third have pledged in some shape or form to get to net zero emissions. That's a pretty major change in the last couple of years. And in most cases, that is a step up in ambition relative to where they were before. So first order question, is it an increase or a drop in ambition compared to what they were at least pledging to do before? Well, it's a step up. That's a good thing. When you get into the details, actually, companies like cities and regions and other countries really vary in terms of how detailed their plans are, how transparent their reporting processes are, who's accountable. So companies have a lot of work to do, but I would say arguably not necessarily more than countries and cities and regions. This offset question is a really interesting one. I think only 2% of these major companies explicitly rule out the use of offsets. And by offsets, I mean these traded carbon credits. I don't mean carbon removal. I think something like 40% of companies explicitly say they will use offsets. And so you're talking about, the majority, nearly 60%, just being ambiguous, not saying whether they will or not. And then of those that do say that they will use offsets, they're very unclear on what kind of quality they will put, what kind of restrictions they'll put on those offsets in terms of how good they're going to be, in terms of knowing that they're really leading to additional effort, that wouldn't have happened if they provided the money. They're going to make sure that these don't do any further sort of environmental or social harms, and actually, improve the environment and communities around them. So actually, the offsetting one is one of those particular grey areas in these kind of net zero pledges. Now, people have been using offsets before net zero came along. I think there's a really interesting question about whether net zero as a concept and as a pledge is leading to more action and better action than before. I think there are a lot of, it links to a lot more general kind of issues in how we make sure that companies and countries and governments, individuals, really deliver on the lofty ambitions they might set out.
So that's about checks and balances, isn't it, behind it? Aside from, obviously, we could speak for the rest of the afternoon just on net zero itself. I'm absolutely sure of it. In addition to one huge, great big project you're working on with the Net Zero Oxford, you're also working on the carbon dioxide removal. How have you managed to swing these two huge projects? And how does the CDR, or the carbon dioxide removal, fit with the net zero story?
How do I manage them? That's a great question. I'm not sure that I do a perfect job myself. I mean, we've got brilliant teams in both cases. So Oxford Net Zero really aims to bring together the different strands of net zero relevant research across the university. And we have legal experts looking at Paris Agreement architecture, or looking at what the legislation is at national levels for corporates and things like that. We have climate scientists. We have economists and people looking at, different policies and incentive structures for reducing emissions through increased renewables, more energy efficiency, and carbon removal. We have people working on nature-based solutions, people looking at geological carbon storage. And then on the carbon dioxide removal side, you're right, we have a project called CORE, or CO2RE, so it's a silent two. The website is co2re.org, and that is actually funded by the UK Research Councils, and that is led by us in Oxford, but that includes 6 other universities as well. So it's a national and very, again, multidisciplinary effort to look specifically at carbon removal. So obviously, carbon removal is really relevant to net zero because at a global level, if you want net zero that isn't absolute zero, so not cutting every single emission there is, then you need carbon removal. And there's some really interesting questions around that. Again, sort of looking at the legal dimensions, looking at public perceptions around different carbon removal methods, looking at how we actually can reliably monitor and verify these processes. So how do we know when a carbon removal activity has happened, and how do we know what happens ultimately to the carbon that's captured and stored in these processes? So yeah, the carbon removal aspect is what CORE focuses on, and that's obviously a vital part of the discussion around net zero. But carbon removal, as I said, is already happening now. So it also plays a role, a limited role, but a role in nearer term targets. And there's a big question as well about whether we're going to need more carbon removal past the point of net zero, either globally, if we end up in a climate which we really don't want to stay in, or nationally. So an important part of fairness around reaching global net zero might be that richer countries with the greatest historical responsibility, like us in the UK, might need to do more than net zero in order to give some room for other countries.
We're talking about carbon removal then as almost an additional bonus buffering service for the global scene as opposed to individual organizations and projects.
So, I mean, yeah, ultimately we're going to need it globally, I think. And what that looks like and how we get it into good, robust, reliable strategy on climate action, I think is a really interesting question. So I wouldn't want anyone to think that it's a buffer in the sense that we can emit too much in the near term, bust our carbon budget, and then it's okay, we can reverse climate change by just putting in loads of carbon removal. We know that there are loads of path dependencies and irreversibilities in the climate system, which just mean that even if we could scale carbon removal to a level where we can significantly dial back global temperature, the world will be a different place on the way back down. So I don't think that that's a good way to think of carbon removal. But I do think if we're trying to work out, well, what's the wide range of actions we want to take now if we really want to get down to net zero on the kind of timescale that gives us a shot at 1.5 degrees, if climate change is really going to progress as badly as many fear it might, then I think having options we know exist that remove carbon and developing some newer technologies, that's a key kind of part of our toolbox, alongside the very many ways we know to reduce emissions and stop making the problem worse in the first place.
Yeah, and I think it's absolutely vital that you've made that clarification on its importance and not just going, it's okay, these will sort it out. So getting into the nitty-gritty then of carbon removal, and we're talking about carbon removal, we're not talking about greenhouse gas removal. I will come back to that point in a moment. What are the options? What are these methods, processes of carbon removal looking like? What's the variety out there?
Yeah, well, in the same way, there are many different ways to cut emissions. There are many different ways to remove carbon dioxide from the atmosphere. So broadly, carbon dioxide removal is any activity which captures that carbon dioxide from the ambient air, from the atmosphere, and stores it away. And that can be in lots of different parts of the Earth system, lots of parts of the carbon cycle. So it can be in trees, in soils, on land broadly. It can be geologically, so putting it in rocks, burying it underground. It can be putting it actually in oceans, or it could even be putting it in durable products. But the key features are it's an active human activity. So the world does a lot of natural carbon removal for us, and that's a great help. But we're talking about additional processes that we intervene with as humans. It's the CO2 has to come from the atmosphere, and it has to be stored durably away. So within that broad definition, there's a whole host of things we can do. So the obvious one is planting new trees. Trees are a brilliant natural way of soaking up CO2 from the atmosphere, growing and locking it away in the tree biomass. There are many things we can do to restore soils as well, put carbon back into soils where we've lost lost a lot of soil carbon. Peatlands are a particularly rich carbon store. I know that's been tree planting and peat restoration have been topics of your previous podcasts. So they're great carbon dioxide removal solutions, actually, when you get those soaking CO2 back up out of the atmosphere. But then there's a range of other things as well. So people are looking at biochar, where you take biomass, which can be from wood or other kind of food wastes and agricultural residues, you pyrolyze it, you turn it into a kind of charcoal, and that actually turns a fraction of the carbon into a very stable portion. And people historically have plowed that into soils, can improve agricultural yields and soil structures. People are now looking at whether that's actually a really good construction material in road base or in buildings. Then there's putting CO2 from the atmosphere into cement to cure it, and then you're locking it up, turning it into a rock. There's biomass with carbon capture and storage, or BECS, as bioenergy with carbon capture and storage, it's sometimes called. We use a lot of biomass for energy already. We typically just vent the CO2 into the atmosphere. What if we capture that and bury it underground so that CO2 doesn't get back into the atmosphere? Then, if done well, that's a kind of net carbon dioxide removal over the life cycle of that process. There is also particular minerals that can be spread on agricultural soils, especially as a kind of alternative to fertilizers. Again, like biochar, can, done well, have a benefit to the soil and to agricultural yields. And then there's direct air capture and storage, which are these new machines, and they get headlines sometimes when they get built. There's a plant that was recently up and running in Iceland, which is literally using energy to and chemicals to process an awful lot of air with fans, extract the CO2, and then bury that underground and make sure that doesn't get back into the atmosphere. So a whole host of different ways in which we can remove CO2 from the air.
And obviously some of those feel quite familiar, the tree planting and protecting and restoring peatlands. The more innovative techie type options seem less familiar to us. How much is that currently going on? Are they still in the sort of pilot trial stage? Which ones of these are likely to be scalable to the point that they're actually useful?
One of the things we've done recently actually is try and assess how much carbon dioxide removal is going on. And yeah, the answer, I think I mentioned earlier, about 2 billion tons of carbon dioxide removal through human activities. And nearly all of that is actually through the way we use land. So it's important to remember that actually the way we use land globally is a net emitter of carbon dioxide. We're chopping down a lot of trees still, sadly. But in other parts of the world where we're not chopping down trees, we're planting new ones. We're restoring soils. And so that adds up to about 2 billion tons. And then a tiny sliver at the end of that, about 2 million tons currently, is these more technological carbon removal options, the bioenergy with CCS, the biochar, tiny little bit of direct air capture and so on. So they're really tiny. I mean, 2 million tons per year, compare that to the net emissions of CO2 of 40 billion tons a year that we're currently putting into the atmosphere. They're tiny, but you have to start somewhere, right? And maybe we can scale them up. It's important to remember that with the fossil fuel industry we've got, the industry we've built that digs fossil CO2 out of the ground in the form of fossil fuels, and then we burn it and emit it and use it, that's had many decades to get absolutely enormous. So, I mean, getting something like bioenergy with carbon capture and storage, or direct air carbon capture and storage, up to the 1 billion ton scale is a non-trivial exercise. So I think there's definitely scope for many, if not all of these methods to work and to scale if done well, but they've got a long way to scale. And I don't think we should be under any illusion that we can just kind of carry on emitting our 14 billion tons of CO2 and think that we're going to get to 40 billion tons of removal and get to net zero that way in the next few decades. So again, we probably want to scale these up and be heading towards the billions of tons per year if we can. We don't know if we can get there, but it makes sense to try, and also to cut our emissions as much as possible in the meantime. And actually, there are really interesting synergies. It's often set up as a kind of, there's this bucket of things that are emissions reductions and this bucket of things that are carbon removals. But there are things that can be done that are really complementary across both. So to give you an example, both BECS and DACS, the bioenergy with carbon capture storage and the direct air carbon capture storage, they require some kind of infrastructure where you can take captured CO2 in a pipeline and dispose of it somewhere underground. And actually, with many other waste problems, we deal with them not only by cutting the amount of waste we put into the environment, but actually actively tidying it up and disposing of it somewhere safe. So if you do that, you have the option to dispose of CO2 that comes from sources like cement plants as well. So a transport and storage infrastructure for CO2 is great for cutting emissions and for carbon removals. Cleaning up our energy supply, if we're going to run processes that create the rocks we need to spread on ground or pump air around fans so we can extract CO2, we need clean energy to do that. So it makes sense to be going really hard on renewables and other zero carbon energy sources, not only to cut emissions, but to enable some of these carbon removal methods as well.
That's, again, it's very interesting that you draw in that part of the story, that actually if one part of this puzzle gets some traction, it draws naturally other parts that will cumulatively benefit over time. I like the fact that clean energy can be, because there's no point using fossil fuel energy to do something nice, otherwise we'd just be going around in circles. I imagine that's what the fossil fuel businesses would like, though, to be able to just business as usual and tag on something nice at the end to sort their problem out.
Well, there's another interesting angle to this is, well, where do we have the skills to build the capability to dispose of CO2? And actually, you'd look to probably the people who've got very, very good and very rich at doing that process in reverse, which is the people who are extracting fossil fuels out of the ground. So I think that does point to, some people get worried about that, and probably with some justification, that carbon capture and storage, which is, a part of the puzzle for both emissions reductions and carbon removal, might be the great get out for fossil fuel companies. Maybe that's a risk. And I think that's something we should definitely think carefully about and make sure that we kind of right size the role of carbon capture and storage in all of this. And actually, there'll be many things we can do that are just flat out cheaper to stop us having to use fossil fuels in the first place. So just economically, it's not sensible to think that carbon capture and storage is going to be enormous. But if you're thinking about, this workforce of many, many people who work in the oil and gas industry, and what can they do that will make a difference to help fix the problem, maybe they're the people we need to help build this kind of disposal infrastructure we need. And that's a part of the fixing the climate story. Definitely not the whole part, but I think quite a strategic part in the whole mix.
Your roles over time have been very closely connected to policy. You give me the impression that you're quite hopeful, actually. Can you see a time where, because at the moment fossil fuel companies are very much the bad guy. Oh, I say guy, I don't mean to be gender specific on that. Is it right that we have, where is it going to come from that's going to put checks in place that actually they do the right thing? Because at the moment they don't look like they're massively doing the right thing.
Gosh, it's interesting you say I'm optimistic. I don't know. Maybe I am a natural optimist. I definitely don't think we've got this problem cracked yet. Otherwise, I would go home and put my feet up. I think we have made a lot of progress in some small, very limited areas. So the costs of wind and solar and batteries are coming down really fast. And as I said, if you can clean up your electricity supply, you not only cut out emissions from the coal and gas that you were using to generate electricity before, but you can electrify other things. We're having some successes elsewhere. And I think the more we look at the problem, the more we will find solutions. So there's that kind of upside. But actually, if you look, taking the UK as an example, if you look at how the UK has actually done since it first arguably got serious about climate in the early 2000s, and certainly in 2008, the Climate Change Act, what you see is that we have tended to overestimate how much energy we will need. So actually, the big financial crisis in 2008, 2009 was unfurling as the Climate Change Act went through, and all the modelling we did at the CCC assumed that the UK economy was going to keep growing, there wouldn't be any problems, and we ended up assuming far more demand for energy and stuff than has actually materialised over the previous 10 years, because sadly we've had a lot of economic hardship. But in a sense, that's good for emissions because it's meant less demand, less traveling by road transport, aviation, less buying of stuff. So in a sense, that the kind of demand for stuff picture has turned out okay, but we've turned out surprisingly okay in terms of bringing down the costs of particularly wind power in the UK. So those are some upsides. Some downsides are we've done spectacularly badly in other areas like rolling out insulation for homes. Actually, building nuclear power stations was certainly part of the plan. Building carbon capture and storage infrastructure was part of the plan, and neither of those have happened. So it's very much a mixed bag. Certainly the forecasts suggest that we're not on track to meet our climate targets as it stands.
I think because of the point that you're making, it makes me consider the report that you've recently been involved with, which is the State of Carbon Dioxide Removal Report.
Yeah.
Because that connects with, I was wondering where you were hoping that audience to that report is. What was the purpose of that report? Who are you hoping to connect it with to make these sorts of changes that you're hoping will transpire?
So the State of Carbon Dioxide Removal report came about actually because we were getting up and running with our research program on carbon dioxide removal in the UK. And at the same time, researchers in other countries were spinning up their own research programs on carbon dioxide removal because it was becoming a topic of interest in various places. And we got together and we thought, wouldn't it be nice to come together and actually collaborate on something that's going to be useful? And we shared this view that it's, despite carbon dioxide removal getting increasing amounts of attention in some areas of policymaking and in some companies as well, getting a few more media headlines, it was remarkably hard to answer some basic questions like how much carbon dioxide removal is happening, how much is in pathways to stay below 2 degrees or 1.5 degrees, how much have governments and companies actually pledged to do, and how does that stack up in terms of whether we're on track or not. So that was the motivation for it. And I guess we hope that it's useful. We're not really, I wouldn't say that we're advocating that there's a certain way to do carbon dioxide removal, or even that we need to do X amount more, as indicated by the pathways or other. What we're trying to do is put good data into the debate so that people can have better conversations about this stuff. And it's interesting that people have read different things into the report, and they're all kind of valid, I'd say. Some saying, well, the amount of carbon dioxide removal in these pathways is hopelessly large. We need to double down on emissions reductions. Others have said, well, the amount of emissions reductions in these paths are hopelessly large, so we really need to get going with carbon dioxide removal now. But I think at least having numbers, so we've estimated how much is happening. We've shown that countries have pledged in their action plans to 2030, their nationally determined commitments, as they're called, to increase the amount of carbon removal, but entirely on land. And there's no talk about the newer technologies at the moment. And we can already see a gap between what's in these pathways, the kind of pathways considered by the Intergovernmental Panel on Climate Change, and what's in government pledges by 2030. And that gap grows further, actually, out to 2050. So, yeah, whether it's optimistic or pessimistic, I think is kind of in the eye of the beholder. But hopefully now there's more data, and we hope that we update this because it's a really rapidly moving sector. So, no doubt more pledges will come along. We'll learn more about which methods are coming on stream, and we'll be able to update this information in the future.
So thinking about the future then, within your dual roles that you've got, what are you hoping that you can deliver on or provide data that will be presumably practically implemented in some way?
Well, in our research projects, we've got 3 aims, actually. And number one is pointed mainly at policymakers, because I think it is national governments at the moment who have the biggest levers to stimulate carbon dioxide removal, or at least think about the best way of putting it or not in their mitigation strategies. So objective 1 is to actually look at the range of different policy interventions that are there. And there's a whole load of different ways that can apply to a whole load of different approaches to carbon dioxide removal. So in the UK, to give example, we already stimulate tree planting through something called the Woodland Carbon Code. There is a scheme which allows landowners, land managers to get money for planting trees as an incentive to do more of it. We've got targets to plant a lot more trees in the UK, and we're currently way off those targets, but we have those targets. And the question is, what might actually work in terms of delivering that. And then if you look through the more kind of technological end, we've got an emissions trading system in the UK. We were part of the EU one when we were part of the EU, and that meant that all industrial facilities that were eligible were under this cap, and they had to make sure that they brought their emissions under the cap, or if they didn't, they had to trade permits with other companies within that overall cap. So it's very different actually to a voluntary carbon offset credit scheme. This was a government regulated carbon trading scheme. And so people are asking, well, maybe carbon removal should go into an emissions trading system or something like that. So our first aim in our research project is to look at the different methods. The US is taking a different approach through tax credits. What might work? What are the options for policymakers in terms of fitting this in the strategy, and then providing incentives to get the right amount of effective carbon removal. Our second aim is to look at the technologies, and we actually work with 5 different projects also funded by the UK research councils that are trialing different carbon dioxide removal methods in different parts of the UK. So these are scientists in universities actually doing these kind of demonstration field scale trials to learn more about them. Are they effective? How can we measure that they're effective? What are their wider impacts and implications for the local communities, for the environment, for soil, air quality, water quality, and so on. And we're also sort of stimulating a few more kind of proof of concept ideas in individual labs and things like that. So we want to expand the range of options for removals and improve those methods we do know about. We also want to fail fast. We want to skim out the ones that actually don't work, right? And the third and final thing is actually sort of capacity building, really, because carbon removal is quite a new enterprise. And so it's not something that we've had loads of researchers or experts working on and talking about for years. So we're trying to bring people together, particularly early career researchers, people who want to study this, to network, to share idea. We've got a secondment scheme where people, if they're working on carbon removal but would really like to work with a research team somewhere for a few months or be placed into a government department or a business in order to help with sort of research and knowledge creation and knowledge translation. We're trying to make that happen. So there's lots of different things we're trying to do, really, just to try and make sure that this field of carbon removal develops well on the kind of timescales we think are needed to get us to hit our targets.
I'm glad you went through those. And what struck me is it is very applicable, close to reality and close to policy and to what's going on the ground, and very collaborative. It kind of feels to me a bit like the COVID scenario, in that research and science is absolutely crucial to getting the future to be bright, to put in layman's terms. And I think with us going through COVID, I wonder if that experience makes your job a little bit easier. Obviously, it's a huge task, but whether you're more listened to as a result of the feeling that, we've had to rely on scientists before to get us out of a terrible hole, and this is actually, a much bigger hole. Do you feel that the momentum is coming, that you're being listened to, that you can be really, really impactful?
COVID weirdly did help us in a very practical sense at the start of this project, because, as I said, we're a collaboration between 7 universities. It's quite hard to get everyone physically into a room, which was, of course, the normal way of doing things pre-COVID. And then I remember when we were developing this project, it was when the first lockdown happened, and suddenly everything switched onto Zoom. No one had heard of Zoom before that. But now essentially nearly all our work is actually done online collaboratively. So in a sense, that makes it easier. It's hard to fully replace the meetings in person, so we do have them occasionally, but it lowers our travel carbon footprint and actually makes it easier to get people together online. I don't know whether COVID has changed people's attitude to listening to scientists. Not in a really, really discernible way, I would say. But we'll see. I'm sure COVID's had many ripples that we're only just starting to sort of understand. I mean, we do a lot of work, as I said, on thinking through the legal, the political, the economic, the ethical, the public engagement aspects of carbon removal. I think another really crucial thing is communities and people on the ground. So there are these researchers working in fields, planting specific crops or applying basalt to agricultural soils and measuring what happens. And there are communities who are increasingly getting involved in this. So there's a really interesting project called the Carbon Community, actually, in Wales, which is looking at woodlands and soils around and trying to get more carbon into them through applying basalts or through applying biochar and other really innovative methods. And that's a really interesting collaboration between scientists, the kind of experts working in universities, also citizen scientists, so kind of hobbyists, and the local community. I think carbon removal as a topic hasn't been discussed much among people. People get now that climate is an issue, and they need to deal with emissions, and that's all right. What's less talked about is the role for carbon removal. So I think engagement with communities and seeing real projects that are actually trying to do carbon removal on the ground makes things much more real, and actually will give us much more rich data than just us sitting here doing our modelling work and thinking about it theoretically.
That project in particular sounds really exciting, and if there are more like them, then that seems like a really positive step. To conclude then, because I could ask you a million more questions, but I am sort of eye on the clock. To finish up, I wonder what your thoughts and feelings are towards net zero 2050, what you think it will look like, how you feel about that. Yes, go for it.
Gosh, a big question. It's definitely not a given that we're going to get there. I mean, we are off track. If I bring it down to UK level rather than global level, I'm excited to see what it'll look like. It will happen just about the time that I'm probably due to retire, all going well. So I look forward to opening the newspaper on 1st of January 2050 and seeing whether we made it or not. I think it'll be a much better world than we're in, not only because we will have cut our emissions and maybe started taking some back out of the atmosphere as well, cleaning up our residual mess, but I think, air quality will be better. I think standard of living, the affordability of energy, they will all be better. So if we get there, I'm very much looking forward to seeing it, but I think we've got an awful lot of work to do to get there. And it means we can't be too picky. Among the options we see that are promising across emissions reduction and carbon removal, if we're serious about getting to net zero by 2050, I don't think we can play too many games in a room of choosing which ones our favorite solutions are. I mean, we definitely need to prioritize making sure we leave the broader environment a better place, giving people better jobs and a better quality of life. But I think there are many ways we can do that. And I hope that, through emissions reduction and carbon removal, we can just build a flat out better world in many different ways.
That's fabulous. I like the fact that you've brought in all those co-benefits of getting this job done, because there are a lot of benefits to be had. We could quite easily focus on we can't do it like this anymore, we can't do it like that. But actually, it is a better landscape if we can do it. So I look forward to that. I share your vision. And thank you so much for your time this afternoon.
My pleasure.
I'm so grateful to Steve for sharing his time to discuss these crucial elements of climate strategy. Net zero is becoming an increasingly familiar term as governments and organisations communicate targets for reducing their impact on climate change. So it was great to get clarity on what this means conceptually and in practice. We're not on target, and reducing emissions will require a massive upsurge in time, effort and money. Steve explained that carbon dioxide removal is neither the silver bullet nor the main focus, but he highlighted its place, detailing the options available. Despite being off target, I for one always feel reassured when listening to academic experts who are at least providing an evidence-based approach to direct policymakers and business leaders. Let's hope they take note. If you want to discover more about Steve's work, see the show notes. In producing this episode, I'd like to thank Andy Shaw for audio editing, Jeremy Jones for providing the music, and to you for listening. Don't forget you can follow the podcast to get automatic access to each new episode, and it would be lovely if you could rate, review and share it too. It really helps. Until next time, bye for now.